Okay, let's talk about these two integrals. The first one is the integral of 1 over secant x plus tangent x. And for the second one, we have this on the top, and the denominator is still the same. Well, think about it. Which one's actually easier? And also, keep in mind, you should pause the video and try these two questions first before you watch the solution, alright? But anyway, let's take a look right here. It looks like this might be easier because on the top is just 1, but you have to really remember what I'm going to tell you. Sometimes when you are doing integrals, the more the better. This right here, it's more straightforward. And the reason is because if you look at the derivative of secant x is secant x times tangent x, and the derivative of tangent x is secant square x, and you can just add them up. So we can do this integral by u sub right away. Let u equal to the denominator, and let's just put down secant x plus tangent x and differentiate both sides. Du, the derivative of this is secant x times tangent x, and we add the derivative of this is secant square x, putting in parentheses, and of course the dx. And you see, this and that are actually the same. The order of addition doesn't matter. So, you look at the top, all this right here along with dx, this right here gives us precisely the du. So we can look at this right here as the integral. And I like to put a 1 on the top and then the d whatever on the side. So let me write that down as 1 over. The denominator here is our u. And all that, it's going to give us du. So we can totally integrate this now, and the integral of 1 over u in the u world is just natural log of absolute value of u. So let's put that down, and because we know u is this, so we can just put that down right away. So we have the secant x plus tangent x inside, and then we are done. Put a plus c. This right here is it. In this case right here, before I show you guys this one, right here, do not factor out the secant x and then cancel things out. In fact, this question right here, it's precisely how we integrate secant x dx. We get this actually. So here's the deal. If you integrate secant x, what you are going to do is you are actually going to multiply the top and bottom by secant x plus tangent x. Let me just write this down right here for you guys real quick. Secant x plus tangent x, like this. And as you can see, because if you want to integrate secant x, you don't have too much things to work with. When you multiply this right here, it's just about right. No more, no less. And you end up with the integral of secant square x plus this times that, which is secant x tangent x all over this denominator. So this is actually the way that this should be a dx. This is actually the standard way to integrate secant x, and this right here is a standard result, right? And now let's talk about how we can do that. Well, in this case, if you let u equal to a denominator, unfortunately, the top is just 1. We don't have this, right? And you don't want to multiply the top and bottom by that. So here's how we can do it. We can write everything in terms of sine and cosine. This is also a strategy. Keep in mind, in an integral, the sine and cosine, they get along with each other really well. They are like the best roommates. So let's see. This right here is just 1 over. This right here is 1 over cosine x plus tangent is the same as sine x over cosine x. And of course, we can put down the dx right here. And notice, I can just clear this complex fraction by multiplying the top and bottom by cosine x. So that this way, on the top, we get the cosine x. On the bottom, this times that, we have 1. This times that, we just have the sine x dx. And right here, we can just go ahead and do u sub. I'll just put it down right here real quick. U equal to the denominator. Let u equal to 1 plus sine x. Because if I differentiate this, the derivative of sine x is precisely cosine x, right? The derivative 1 is 0, so we have this, and then we have the dx. Same thing, this is so nice. The top, cosine x dx, this is our du. So again, we end up with the integral. Let me put a 1 on the top, and the bottom is precisely our u, and all that is the du. So in this case, we also have the natural log absolute value of u, and we don't use this, so we can just put it down right away. 1 plus sine x. And with that, we are done. So that's it.